monitoring for manufacturing setups by distinguished West faculty of IIPM. Followed by this session, we will have an actual deployment of IoT discussed by Deepak Fertilizers and Petrochemicals. This success story will be showcased by Chandanji of Deepak Fertilizers. He is there on the panel along with us. And those who would not know me, my name is Atul Govil, and on behalf of CIOs of India and CXOs of India, I welcome you all in today's session. Just to give you a brief context, I was just reading a literature by Wall Street Journal, which says that based on a survey, almost every industrial manufacturer have faced unplanned downtimes in the past. They've all faced unplanned downtimes. And of all these unplanned downtimes, almost 42% of these downtimes were due to equipment failure. There could be other issues like electrical power failure or some utility failure or some other issues, but but largely these issues were attributed to equipment failure. So which also means that this is a big issue which needs to be addressed. And as we all know, those who were there in the first session, in the last session, Professor Barik had covered how predictive maintenance as a maintenance approach involves understanding of the underlying health of the machine to determine whether or not a corrective action is required. And then to assess the health status of machines, of course, you would need some specific sensors which are used to measure the various machine parameters. It could include vibration, it could include temperature, it could include sound. So we will talk more about these today, wherein Professor Bishwajit will take us through basics of vibration measurement and different tools which are used for measuring of vibrations. So without much ado, let me just request Kamal Karnatak to say a few words so that we can get started with the session. Over to you, Kamal.
Good morning, all the participants who are coming on this Saturday morning. Many of you were part of last session also. So welcome again. As I said last time, come with a training mindset, come with a learning mindset. It may not be a jazzy presentation which we are hearing in other seminars or virtual webinars, but come with a learning mindset so that you can learn more about production facilities. You can learn about condition based monitoring, and today we are covering vibration management. For CIOs of India, let me also tell you that we are doing a lot of learning sessions. If you see this ticker on 11th November, we are having a very good leadership session from 12 p.m. to 1:30. So if you have not registered for the same, you can register for that, and you can also attend that. People who would be attending that session, they would be getting, some of them, lucky winners, would be getting the copy of this book. Paul Dupes, who was a rag picker at some point of time, how he became a CEO of a big company. He is also an athlete. He is also a marathoner. He is also an author. So he would tell 5 leadership traits. What are those 5 leadership traits, and how in this pandemic time you can learn those traits and survive yourself and also for your organization. So with that, let me welcome you all for today's session. Over to Atul.
Thank you, Kamal, and you always surprise us with these nice tech aspects, which you bring on your presentation. Thank you, Kamal. Thank you so much. And so before we start, let me just give you a brief introduction about Professor Bishwajit Mahanto, who is the faculty and head of vibration department at IIPM. IIPM, as I mentioned in the earlier session, it's been in existence for almost 30 years, more than 30 years now. And Professor Bishwajit, he has more than 12 years of experience in the industry and consulting practice, and he specializes in mechanical maintenance condition-based maintenance and training. So that's what he does. So without any further delay, let me start the session, and over to you, Professor Bishwajit.
Hello.
Yeah, we can hear you. Go on.
Yes. Good morning, all. Thank you very much, Atul sir and Kamal sir, for that excellent introduction. So without further ado, we'll start the session. So in the first session of the program, Mr. Barik sir has covered about the maintenance philosophy, its concepts, its objective, classification, types, strategy, troubleshooting guidelines, reasons for machine failure. He has also discussed about the requisites for maintainability, availability, and quality. And he had also explained the different types of condition monitoring technologies, principles of CBM, its objectives, methods of CBM, implementation, and its advantage. So I welcome all the participants for the second session on CBM system. Today we are going to discuss about vibration monitoring and analysis. So in this 1 hour of session, we will understand the basics of vibration and the best practices followed in industry. I hope you will enjoy the session and will get benefit out of it. So today's agenda will be what is vibration, what are the characteristics of vibration, what are the different types of vibration instruments till date we are using, and what are the steps for vibration analysis, and how to assess the condition of the machine using vibration analysis.
Professor, I was just wondering, can you put on the slides, please? Because we are unable to, I think you've not put on the slides as yet. You can just showcase or share the screen, please.
Okay. Just a minute.
Sure. Maybe you can take Barik sir's help if he's around. There would be a shared screen at the bottom. Yeah,
Yes,
you can see the
already.
screen. It came. Yeah, it is there. Go on, please.
Okay.
Perfect. I think you can put it on the presentation mode. Great.
Yeah.
Thank you.
So this is a normal case in our heart. As you can say, we also do condition monitoring in our heart. And day-to-day life, we are having vibration in the trains, buildings, automobiles, machines. So in any organization, assets are needed to make product or to provide services. The main objective of implementing condition monitoring in an organization is to ensure that assets are available when needed in a cost-effective manner, because ultimate plant needs how their cost, how they will be benefited, and how to minimize their expenses in maintenance and other things. So how do you the performance of an asset, how do you determine? So basically there are three factors. First one is inherent reliability. So inherent reliability is nothing but how a machine is designed and how much efficiency a machine can give. Suppose a machine is designed for 85% efficiency, but you want to improve its efficiency to 88%. So you can do that. At that stage, you need to redesign the machine. And second thing is operating environment, how it will be operated. Because in vibration analysis, 40% of failures are result of due to operation failure. if a maintenance and operation team are well performing their or operating their machine, then these 40% failures can be saved. And third one is maintenance plan. How we need to maintain our machine. We should know the latest types of maintenance strategy, latest type of maintenance techniques, so that we can maintain the machine in advance. So you might have learned from the previous classes, there are more than 10 important technology used in CBM. But among that, vibration analysis is considered as the grandfather of CBM because it provides the foundation of most facility CBM program. So let's go to the topic. What is vibration? So anything which is oscillating from its equilibrium position, that is where net force acting on the body is zero, that create vibration. So all rotating machines such as fans, pumps, motors, turbines, when they are operating, they generate forces which cause the machine to vibrate, and then it is transferred to the bearings. So the forces are result of all rotational and frictional forces. So before you want to become an expert vibration analyst, or you need to start with the basics. So what you need to know is how to make the measurement. You need to know what are you measuring. You need to know what the signals look like, and you will be able to know how to interpret the final data graphically. So what causes vibration in the machine? Vibration is due to induced force and freedom for movement. So induced force, that is force generated within the machine, it can be due to unbalance, it can be due to misalignment, it can be due to damaged bearing. So this creates some induced force in the machine due to which we can feel vibration. And the second one is freedom for movement or degree of freedom. Any machine has its own degree of freedom. So we need to see at which direction or which movement it is creating. So we need to arrest those vibrations in that all directions. Then what are the harmful effects of excess vibration? Suppose we are having vibration in the machine. So how it can be harmful to machine as well as to the operating environment? First is it will generally create increased load on bearings, because bearing is the area where all the forces bearing will absorb. So generally if load on the bearing is increased, it will reduce the bearing life, because if load is doubled, bearing life reduces to about 90%. Similarly, if speed is doubled, bearing life also reduces to 50%. Then comes the higher force on mounting. That is, if forces are high, then your foundation bolts will become loose, your structure will become crack. What happens when machine runs? Things become loose. Pipes, supports, flanges, bearing, foundation ball. This can become loose due to low frequency vibration constantly being generated by machine RPM. So what would happen when they become loose? Damping would increase as things rub against one another. So then next question come, what would happen when things rub against each other? A spectrum of frequency is imposed on the system called down frequency. It excites the natural frequency of the system. Decreased equipment, increased stresses on machine, what I have discussed, and decreased equipment efficiency. Because ultimately, if vibration is there, vibration present in a machine, our productivity will be low due to more failure of the machines. So we need to identify that. And same is related to reduce output quality. If a machine is vibrating in a unplanned manner, definitely your output will be not good. Increase maintenance cost due to more component failures and unplanned operation, definitely. And last, unsafe operating environment. Definitely if vibration is there, because it is also considered as safety as a factor, because so many of the high vibrating machines or has been prevented by using guardrails or remote sensing system so that when people come nearer to the machine, it automatically stops the machine.
So
So next,
Bishwajit ji, I'm sorry, I'm just interrupting. So I'll just give a additional context from the to the
sure,
CIOs.
sure, sure.
So no, we when we talk about new age technologies, we could either talk about how do we add value to our inputs, how do particularly for manufacturing, how do we have strategic sourcing in place so that we purchase at the lowest cost. Otherwise, it could be around our operations. So how do we convert the raw materials and input materials to finished goods? So that's the operations part. And then finally, it could be for the sales and distribution part. Now, if you see what Bishwajit ji has just mentioned in the previous slide, we are talking about when you talk about operations. So we have to see how well are we running our assets. Are we running it at the most optimal level, or is it running at a suboptimal level? Is it can it potentially create a hazard while it is running? So which is to say that is it an unsafe condition in which it is running, wherein it can create a risk to the environment or risk to the individual. So to do that, you need to do some kind of condition monitoring of those critical assets or those identified assets. And then to do that, as Bishwajit just mentioned, vibration is one of the most important parameter to be tracked, because if the machine is running with very high vibrations, it means it may lead to a failure, and that failure could be catastrophic, or it could be just limited to the equipment not being available. So that's the context with which we need to think through. Some of the slides you may find is slightly technical, but it's important to build on the context, because you can only build solutions if you have a broad understanding of the overarching requirements. Over to you, Bishwajit ji. I'm sorry I took a minute
Sorry.
just to
Thank
give
you,
the
thank you.
context. Yeah.
So where can we apply vibration monitoring? So basically it is meant for rotating machine, but as well as you can monitor for reciprocating machine as well as structure and foundation. So you can apply on fans, blowers, compressor, engine, turbine, alternator, pumps, gearbox, ball mill, electric motors, and then many other items. And what are the problems we can identify? Unbalance. It is a major vibration problem in industry. Most of the machine face this type of problem. Misalignment, whether it can be angular misalignment, parallel misalignment, or both. Mechanical looseness, looseness of the bolt, looseness of the system, looseness of the supporting structure. Anti-friction sleeve bearing defects, that is defects in bearing due to crack or due to inadequate lubrication or due to inner rest damage, outer rest damage, or due to case defect. Gear defect, similarly, you can have like gear misalignment, then backlash error, then gear eccentricity. Resonance plays a very important factor, because what is resonance? Every object or everything has natural frequency. Natural frequency can be 1 to infinity. So when a forced frequency, that is when a machine is having defect, it will induce force. So when this forced frequency coincide with the natural frequency of the machine, it will generate a high vibration. And due to resonance, your vibration, even if a low vibration, can damage the structure. Then belt defects, whether it is pulley alignment, whether alignment, misalignment, whether it is due to belt tension, everything you can identify. Then impeller and blade defects, whether impeller had got cracked, whether impeller is loose, you can identify. Bent shaft, whether it is bent near the center or near the edge, you can find out. And electrical problem, partially it is electrical problem, it is slightly, it will give you an indication, but better you can identify electrical problems through motor current signature analysis. Then also about reciprocating machines, and sometimes for critical problem, maybe if you are unable to find distinguish whether vibration is due to my machine or due to my structure, or there is some process changes, you can identify through it. So this comes the what are the main benefits of vibration? Why we are doing? There are so many techniques, but what is the main purpose or benefits of vibration? Transition from run to failure to proactive style maintenance. Because already in industry, we should always plan ahead. We should always plan our maintenance schedule, everything, either a few days before, few months before. So we should always have in a proactive style of approach towards maintenance. Then accept and testing of new equipment installation. So here vibration analysis plays a very major part. Suppose you are install one new machine, and if you want to check whether after commissioning whether my machine is operating in a normal condition or not, it can be done through vibration analysis because we have got certain ISO standard. With that we can compare whether my machine is in normal condition, and after that I can supply to the industry, yes it is okay, now you can run your machine. Then increase operating reliability, because here OE plays a very important part, because for OE your ability into performance into quality it should be high. So in mainly in TPM, what total productive maintenance, most of the small minor jobs has been done by the operators. That means operator is the main focus for maintenance in TPM. And then increase mean time between failure. So what is MTBF? So it is the average length of time between one failure and another for a component, or we can say that it is a reciprocal of failure rate. Then implement just in time spare part inventory, because if we are doing vibration analysis at the right time, we can have our stocks or inventory in the scheduled time. We no need to procure or we have to wait for the spare parts to come, then we can replace. So it's help in just in time spare inventory. Also, we should try to increase our range time. So range time is what? The time that the technician spends using their tools. So already we should type that suppose we are doing any maintenance activities. So what are the time the technician takes? We should increase that time so that very quickly and without wasting the time, he can do the maintenance job. Then improve maintenance management, because you should select and apply the appropriate metrics what is said as OE to access current condition and capabilities of equipment. Then improve management and lower utility bills. Generally, if your machines are running in good condition, your utility bills will be obviously less. Now see on practical example of how vibration analysis can be a cost benefit. So in most of the equipments, unbalance is a great problem. Just like suppose you have an impeller which has an unbalance of 28 gram at the edge of 1 meter dia. And this unbalance of 28 gram will have an additional 500 kg of load, and it will reduce the bearing life of to 25%. So if a bearing is run down to failure, it would have cost additional cost of changing the entire bearing plus shaft plus motor unit and many more. So the total replacement cost will be around 10 times more than a bearing cost. Let's see how it is. Suppose cost of bearing is rupees 9,000 and its replacement cost alone is 1,000. So total cost is 10,000. That means what I mean to say, I am doing vibration monitoring in a machine and I have found that the bearing is damaged. So I would purchase a new bearing and replace. So total cost is around 10,000. But if I am unable to identify what is the problem and I simply let the machine to run to failure, then what will happen? First bearing will get damaged, then shaft will get damaged, then motor will get damaged, then we have to call some extra hot service. So what is the total cost? The cost of bearing plus shaft plus motor, let's say around 60,000. Cost of labor for replacing the entire unit, let's say 10,000. Loss production, because obviously production will be hampered. So let's say minimum 60,000. Price of hot short service, because of urgent priority service, you have to call your people for overtime and what else. It will be around 5,000. So in total 1,35,000, and which will have extra inventory maintenance or the transport charge of the equipment. So in the above figure, if I am doing vibration analysis, it cost is around 10,000, because I have already identified what is the problem and I'm doing maintenance according to that. But if I'm ignoring that problem, then I have to pay 1,35,000. So obviously it is 10 times more, cost is increased. Second case, in planetary gearbox, there was high amplitude at GMF, gear mesh frequency, and its seconds harmonic along with the sideband and lower side. So what is GMF? That is I will explain afterwards. So basically planetary gearbox, it is used for high reduction ratio, and it is mostly used in wind turbine, because in many foreign countries they mostly generate powers using wind turbine. So what I suggest, so there we have done analysis. We found that gear shaft is slightly bent and loose. But since planetary gear has more than 3 gears, because the sun gear and the planet gear, so identifying gearbox were found to be difficult. So we did analysis on the time waveform. So it have given the indication that its teeth were having defect. And after that, because for evaluation of problem in gear, you need to do vibration analysis as well as oil analysis. These are the two analysis uh, compulsory you have to do for gearbox analysis. So in oil analysis, it was found that yes, the teeth were wearing out. So the gearbox was disassembled and all the 3 gears were found to have defective teeth. So if the problem has not been diagnosed, it would have ended in catastrophic failure. That is total uh, failure of the equipment. So here the gear replacement cost plus the loss in production plus downtime loss in labor, all should be considered. So what are the fundamental realities? All machine while running will vibrate. It is a general phenomena. If a machine is running, it will vibrate, whether it will be low or high depending upon the application, but it will vibrate. But when a vibration level will increase, it will having some trouble. So each trouble which having its own pattern, its own signature. Not every type of problem will having the different types of pattern. So as an analyst, we need to study that pattern and need to diagnostics. So before going to start how to understand the characteristics of vibration, you should have an simple example of spring mass system, because what all time waveform the system is, the sensor is generating or the instrument is generating, it's all depend upon the spring mass, because this vibration, the theory of vibration follows the path of simple harmonic motion. Because when a suspended mass is attached to a spring, and let's say I have attached some pencil to the suspended mass, it will draw a waveform. And in the two diagram here, so you will be seen that in first figure the frequency is low, and the second it is vibrating at high frequency. So how to measure a machine is having vibration? What all characteristics we need to know in order to identify how much is the vibration and from where vibration is coming and how to confirm. So first let's talk about amplitude. Amplitude is nothing but it determines the severity of vibration, whether vibration is high or low. We can evaluate by seeing the amplitude. So amplitude had got 3 parameters: displacement, velocity, and acceleration. So how far, I have shown here a spring mass system. So how far up and down the spring is moved, it is called displacement. Then how fast the mass move as it going up and down is called velocity. Velocity is nothing but rate of change of displacement. And how much is it is accelerating, it is known as acceleration. So for any vibration, any machines, suppose you want to take vibration, we have to take in three different units. Either we can take displacement, either we can take velocity, either we can take acceleration. But it will depends on which machine, which type of unit we should take. I will tell in the coming slide. So amplitude is basically nothing but it will determine whether my vibration is low or high. That means it will determine what is the severity of vibration. Then next come frequency. Frequency is nothing but number of oscillations per second. So what is frequency and how it is going to help? So frequency will tell us what is the source of vibration, whether it is coming from motor, whether it is coming from shaft, whether it is coming from gearbox, whether it is coming from bearing. So it will tell us about the source of vibration, where from vibration is coming. Then we have got phase. Phase will identify the how the shaft is moving inside the bearing housing. So phase will give a confirmation. Suppose because what happened in vibration analysis, many problem will have the similar pattern. You will have similar pattern for unbalance, similar pattern for misalignment, same type of spectrum it will generate. So how could you identify? You can identify by using phase. Same thing, this is the low frequency vibration, this is high frequency vibration. What all I have discussed, amplitude tells us about the severity of problem. And this is velocity, rate of change of displacement. It will help us to know the source of vibration. This is low velocity, this is high velocity. Acceleration, the rate of change of velocity. Then what are its units? Because this is a very important thing. Suppose you have got information from the online system, or you have taken vibration reading from the instrument. You need to know the what are the units of vibration. So generally for displacement, we are measuring in microns. For velocity, mm per second, acceleration g, acceleration envelope ge, and spike energy ge. Spike energy we are using most case in order to identify defects in the bearing, because whenever a defects in the whenever a bearing is having defect, it will generate peak at ultrasonic zone. So we can use by using vibration analyzer, or you can use ultrasound instruments available in the market, because ultrasound instrument they will also help to identify whether I am providing adequate amount of lubrication or not, and what are the early stage of bearing defect we can find through ultrasound. So when we are capturing vibration, we are getting normally a sinusoidal wave. So here 0, 90, 180, 270 and 360. So this complete rotation is represented by a sine wave. And from here to here, it is called as one cycle. Means one cycle of cycles per minute or cycles per second. So for velocity, we normally use RMS as the preferred scale, because RMS is the total energy contained in the wave. And for displacement what I told, how much it is going from its rest position, whether it is going towards up or going toward down. So what is the total displacement? So in vibration, We have
So
defined
I think just one sec, Vishwajit ji. I think the context, just to draw a context about, just to give you the context to of these parameters. So what Vishwajit ji is just mentioning is what are those parameters of interest? Because if I say I want to measure vibration, so what are those parameters which need to be measured? Maybe you can apply technology, you can do a handheld device, you can do whatever, but ultimately we need to know which all parameters are of interest. Because like we measure sales, so we measure that, no, what are the number of SKUs we are producing, what is the number, what is the volume of sales, at what pricing we are selling, what is the margin we are getting. Likewise, in this context, it we need to know these parameters of interest, and then we see how important, or how of relative importance each of these parameters are in the field of condition based maintenance. So that's the overall premise with which Vijay is just trying to highlight. Go on, Bishwajit, please.
Yes, yes. Right, sir. You have given an exact indication. So we need to know these parameters, because suppose we are finally getting the data by online or offline. We need to know what these instruments are measuring or what they are capable of. So mostly when we will generate a graph, or when we will get your time domain, it will be in x-axis your frequency will be there, and y-axis amplitude will be there. Amplitude can be velocity or displacement or acceleration, it depending upon the application. So which unit we should take for measuring vibration, displacement, velocity or acceleration, it all depends upon the RPM of the machine. Suppose a machine is running at 0 to 600 RPM, not 0, for less than 600 RPM, then we should take displacement, because below 600 RPM, very little vibration in terms of acceleration is produced or terms of velocity. Similarly, for velocity, 600 to 60,000 CPM means or cycles per minute. So if a machine is running between 600 to 60,000 CPM, then we can use velocity. And above 60,000, acceleration is used, because in high frequency range, acceleration value yield more significant values than velocity or displacement. So these things we should keep in mind, which type of machine, which unit you should use. Otherwise, you will not get the data, and your FFT or time FFT will not show what is the defect in the machine. So this should be taken care of. What are the units you need to take, and for what RPM you need to check this. In this graph, it is explained that your x-axis is frequency and y-axis is amplitude. So you can clearly see that displacement is more better for low RPM. Acceleration is good for high RPM, because acceleration is indication of force and displacement is stress, and velocity is normally used. So for every machine, because every machine comes within a range of 600 to 60,000, displacement velocity is often used. It is the most suitable parameter because it determines the fatigue of the machine. Let's say, for example, how these peaks are being generated. Suppose this is a wheel or impeller, you can say. Its speed is around 1000 RPM. This red spot is having the unbalanced weight, and we have got 4 spokes in order to identify what is the problem, and number of stars equal to 8. So if I put a light on it, and on one complete cycle means its speed is around 1000 RPM. That is, in 1 minute it will be covering 1000 speed. So what are the type of defects we can have? See, if red spot, how many times the red spot is touching this defect in 1 cycles per minute, 1 RPM, one time. And how many times the spokes are touching this defect? 4 times. And how many times the stars are touching these defects? 8 times. So generally you will get into this RPM of the machine. Suppose the machine RPM is 1000 RPM and you have got this heavy red spot. So this heavy red spot will strike this stick one time. In one revolution it will hit the stick one time. So you will get high peak at 1000 RPM. Similarly, if you are having problem in number of spokes, so it will get peak at 4000 RPM because number of spokes is 4. So 1000 into number of spokes is equal to 4000 RPM. And similarly, if you are having defect in stars, so it will in one revolution it will hit this stick 8 times. So you will get at 1000 into 8, 8000 CPMs or cycles per minute. So depending upon the machine and its number of blades, number of vanes, you will get your peaks accordingly. So this is the more benefit of frequency analysis. Same thing you can get with bearing defect, whether it is having a problem in inner race, outer race, gauge. It will generate peaks into the bearing defect, that is number of balls into RPM of that machine. At that frequency, your peak will be generated. And this is spike energy. What I told is shock pulse. It is generally used for identify defect, early defect in a bearing by seeing the peak in the ultrasonic zone. Phase I have discussed is nothing but the position of two parts, how the shaft is moving. Mostly you have seen in turbines, two proximity probes are installed 90-degree apart. They are used basically to locate how the shaft is moving inside the bearing. This thing I have told that phase analysis is mostly used to confirm the problem. Amplitude is used to know the severity of vibration, how whether my vibration is high or low. Frequency will tell what is the source of vibration, whether it is coming from motor, gearbox, bearing, belt. It will define the source. And phase is confirmed. In vibration analysis, in electrical, phase will be something like leading lagging factor, but in vibration we mostly use the phase for confirmation of the problem. In this simple case, we have taken phase angle at between B and C. So as a general rule, if between phase angle between B and C is 180 degree, we can say that these two bolts are loose. So typically how we can measure phase? You can simply put a sticker on the shaft and use stroboscopic light. It will tell you the difference between your sensor and your sticker. Then it will be represented in angle. This is called absolute phase. And relative phase is something, if you are having dual channel analyzer, it will give your phase angle between one channel, one sensor and another sensor. So this is called as relative phase. So when you will see that your problem is identified. Suppose if both the sensors are moving in the same direction, that is both are starting from 0 degree, their time domain are starting from 0 degree, then we can say that they are in phase. If one time domain starts from 0 degree and another time domain starts from 90 degree, we can say that they are out of phase. So when two phases are out of phase, then we can predict that yes, it is having some problem. So these are the how to measure phase. These are the one. This is one sensor. This is one sensor. So if they are both are moving in the same time domain or same direction, then we can say that vibration is normal.
I think this is quite interesting and such a good video also you have showcased, Bishwajit ji. I think just to summarize till the time what we have covered till so far is That now you spoke about the common causes of vibration on a rotary machine, which could be in unbalance,
Yeah.
misalignment, it could be
Yeah.
bent shaft or mechanical looseness,
Yeah.
or it could be related to some bearing issues,
Yeah.
resonance conditions you spoke about. You
Yeah.
also spoke about electrical defects. And then now you are covering that, no, how do we
Confirm.
acquire data, and once we have acquired data, how do we interpret that data to
Yes.
arrive at what is the precise reason of this high vibration, or high, it could be an frequency parameter, it could be the amplitude parameter, or it could be the acceleration or velocity parameter. So based on that, we are making a interpretation to be able to narrow down on these precise reason, so that we will be able to act on it and rectify the reason at the next available opportunity.
Yes, because when we are collecting and storing data to show to our colleagues or client, we need to have some convention for presenting the data. So we can justify using phase analysis. And phase readings have got a very important part. It is mostly used for balancing, for diagnosing common machine faults, for verifying resonance. Resonance, you can, if a machine is having resonance problem, you can confirm through phase. Then understanding how structure moves, how shaft moves, because these are invisible. So we need to see from outside. So that can be done through phase. That is nothing but orbit analysis. It is a higher level analysis that can be done through phase analysis. So these are the latest instrument. What till date many industry have been following, reputed industry like NTPC, ICL. These are Emerson, Escape, Emil. These are the leading manufacturers. So initially, when this IoT sensor were not there, initially two types of instruments are available in the market. First is analyzer, and second one is meter. A meter, just like a normal thermometer, you can get only the readings. But analyzer has wide variety of application. You can do enormous thing in analyzer. It has got FFT, it has got time waveform, it has got bump testing to know what is whether the machine is, in order to calculate the natural frequency of the machine. You can calculate what is the at what RPM your natural frequency is there, and you can also calculate critical speed of the machine, because in turbine or many other high speed machine, critical speed plays a very important factor. And when you run the machine in critical speed, a small vibration can total damage the equipment. So
Yeah.
these are different types of analyzer, meter, and different types of sensors. First one is displacement center sensor. This is mostly used in turbine, or you can say these are eddy current probes. In most of the turbine or high speed machines, you must have seen this type of arrangement, because Bentley nowadays, he was earlier providing, now also is providing, and many other companies are there who, because these online instruments, non-contact type, are basically used for critical machine, where 5 minutes of downtime can hamper lots of production cost. So they are permanently installed on the machines. So these are that sensor are all displacement sensor. Then velocity sensor, it is nowadays no, they are not using, but in main today's generation they are using piezoelectric accelerometer. In most of the analyzer, we are having piezoelectric accelerometer, because here you can have you can measure acceleration, and then by single integration you can measure velocity, then by double integration you can measure displacement. What in case of displacement sensor, you will get only displacement reading. Velocity sensor, you will get velocity and displacement. Whereas accelerometer, you will get three readings: acceleration, velocity, and displacement. So this is the most generally used sensor in today's industries. And after accelerometer, then came triaxial accelerometer. Because whenever you are measuring vibration, you are normally measuring in three directions: horizontally, vertical, and axial. So here now in the modern era, triaxial accelerometer have been used by most of the industries. Here at one time you can get readings in three directions: horizontal, vertical, and axial.
And don't go.
Then how this instrument works? Suppose this is a motor. Then by using accelerometer, we are converting this data, we are getting acceleration data. Then by converting into, doing integration, we are getting velocity. So this is the actual raw data is time waveform. So from a time waveform, by using fast Fourier transformation, we are finally getting frequency spectrum. So this is our final output. So what are the guidelines for measurement? This should be the very important factor. How should we measure? Mount very close to the bearing. So whenever you are mounting the sensor, it should be 90° to the bearing, most probably to the bearing center, and make sure your accelerometer is firmly attached. That means an accelerometer must be attached so that it does not rock or move independently of the component. Because if your accelerometer is loose, it will produce some distorted signals by its own individual movements, and therefore it can give you wrong message. So if your sensor is giving wrong message, then the total analysis will be bad. So most preferably stud mounting is preferred as the best way of doing that. Make sure accelerometer is oriented correctly, because what I said that for different types of faults in different direction we need to take reading. Likewise for unbalance we need to take in a horizontal direction. Like for misalignment we should to take in axial direction. So for different orientation, so this orientation should be kept in mind. Then mount the same accelerometer in the same location. This is a very important factor, because every time, whether you take readings in suppose in a year January, February, March, April, you should always take reading on the same location, because the same location will give you the current pattern of the total, you can have the total pattern of the entire history of that machine. So if you are changing the position, suppose A has taken far from the bearing position, B has taken little nearer to a bearing position. So that should be the main purpose, is you should have the repeatability. The location should be same. So you can do it by, whether you can mark it by paint or something in the machine, so that if anyone takes a reading, they will put your accelerometer in the same location. Then mount the accelerometer on something substantial. So accelerometer should never be mounted to the flexible part of the machine, because when you will mount, same thing, your spectrum will be distorted by the flapping of the flexible part. Then what are the three direction which I have told? Normally
I think I'm sorry, I'm interrupting. I think we had a question from one of the participant on the very precise thing which you are talking about. Jiten Singh had asked the question, and I think this is what Jiten ji you wanted to ask. What are these three axes on which we can make measurements? Go on, Bishwajit ji, please.
Yes, thank you. So at what axis we should measure? Normally, three axis is the most important thing, and after that you can take depending upon the application. What application I will take. So normally, horizontal measurement typically shows the most vibration due to, because what happen, machine is more flexible in horizontal plane. Also, imbalance is the most common problem, and it produces a radial vibration, that is part vertical and part horizontal. So because the machine is usually more flexible in horizontal plane, excessive horizontal vibration is a good indicator of unbalance. Then same thing, vertical direction. So vertical direction, so less vibration than horizontal, because vertical vibration due to gravity, its weight will be acting downwards. Then we have also put some bolts to don't allow to the machine to the move. So vertical vibration will be less as compared to horizontal vibration or axial vibration, with a limitation that suppose your foundation or your bolts or supporting system is weak, then vertical vibration can go high. And same axial vibration we are measuring in order to know the axial, because shaft is axial. So whether whenever you are having bent shaft or misalignment, definitely it will have vibration in axial direction. So these are the three possible and more important direction we need to do for vibration analysis. So where we should take? At the bearing housing, because bearing is stiff, all reaction forces passes through the bearing, because bearing means it is absorbing load. Its function is to absorb the load. So this is, if suppose the layman is going to start for vibration analysis. So what he can have some steps, so he can able to identify it. Physically observe the machine, because visual inspection plays a very important part in order to analyze the machine. Look, listen, feel. These are the very important facts. Then draw a machine sketch indicating major items, sub-assembly, note down engineering parameters, whether your pressure, temperature, everything you need to know. Then note down maintenance history, because you do not know what maintenance has done before, and you are going to analyze that machine. You will not get any clear idea, just like a detective. When a detective finds a thief or something, he need to ask what happened in the past, which place you have gone there, what all maintenance activities. Just like so, vibration is just like you are a detective, and you are going to find out the faults in a machine. So note down the common parameters. Tell what I said, like temperature, then oil condition, then whether there is some leakage, and whether some hot air is passing. That thing you need to see.
So
So the machine
I
is,
think just hold on, Vishwajit ji, just to build on the same point. I think as you rightly mentioned, first of all, for suppose if we talk about the leaders who are present today, if they have to go back to their setup, first of all, you may need to discuss that what are the important machines or critical machines which you need to include in this condition based monitoring program. So that is the first thing. Then after you have done that, maybe it could be based on the criticality of the machine, it could be because of any safety issues which you have faced in the past, or due to the cost aspects wherein cost of maintenance was phenomenal. So based on that, you define which all equipments you would include in the program. Then you define what are the baseline limits of the vibration for each machine, so that no you know what is the baseline numbers, and then you define the checkpoints or which all points need to be measured at what frequency. If there is something, there is a need to put online vibration analyzer, that can also be provided, or if it is something to be done on a periodic basis, that could be done manually. So this is how you basically create the whole vibration monitoring program, and then you can continually have a view of the condition of the machine, and then you can decide on the course of action to be taken as and when any event occurs. So this is what briefly I just wanted to summarize for the benefit of the fellow CIOs and leaders. Go on, Bishwajit. Thank you so much.
thank you, sir. So these are the normal ratings you should know in order to diagnose the machine: motor, kilowatt, RPM, gearing details, machine RPM, number of blades, bearing, gearbox, types of gear, number of gear teeth. These all inputs you need to know for to diagnose a machine. Then how to assess the condition of the machine. So there are 4 ways. Either you should rely on ISO 10816 standards or manufacturer guidelines, because OEM, your original equipment manufacturer, he must might have provided guidelines and what is the safe vibration limits you can run your machine. And third is comparison. Compare. Suppose motor A with same rating, same RPM, same purpose, its vibration is this much. Then same motor, another motor B. So compare with do whether your vibration is same or not. Then trending. Suppose you have nothing, you have not got ISO standard, you have don't have any manufacturing guidelines because you have not purchased equipment from OEM, you have bought from a local vendor. So that thing, what Atul sir had tell, when you don't have nothing, you can create a baseline. Suppose when my machine is working in a safe vibration level, what was that reading? And then I will compare the baseline readings to my current readings. So this all. Thank you, Atul sir.
Great. Thank you. Are we done with it? Is it completed, or you have any further slides?
Completed. It's completed. Any questions?
Great. I think if there are any
I
questions,
will solve
maybe
in the chat box. I will let you know in the chat box.
correct. Great. I think thank you. I would request is if Amit Saluja ji, are you there on the call, or can you unmute yourself? Okay, I think we'll get him on. Amit Saluja ji from NASSCOM, he's there on the call. I'll just ask him to unmute himself. But in the interim, I would request if there are any questions for Vishwajit ji, we can have we can put it on the chat box. And I would now request Mr. Chandan ji from Deepak Fertilizers and Petrochemicals to share his views about how he has implemented new age technologies, IoT, and procedures in maintenance planning and condition monitoring in Deepak Fertilizers and Petrochemicals. And before he does so, I just want to introduce that Chandanji is a mechanical engineer with more than 12 years of rich experience in condition monitoring. And he is a category 2 vibration analyst. So look forward to for learnings from you, Chandanji, if you can just showcase your screen and take us through. Chandanji, are you there?
Hi, sir. Good morning, sir.
Yeah, hi. Good morning.
Sir, myself Chandan from Deepak Fertilizer and Petrochemical Corporation Limited, Dahej.
Very good.
Okay, sir. I have a total year of experience, 12 years of experience, and I have 8 years of experience in condition monitoring department. So my previous organization was JSW Energy Limited. So we are working in the condition monitoring field. So we are regularly monitoring the equipment based on the criticality of equipment, like criticality A, B, and C. So based on the criticality of equipment, we are collecting.
Chandanji, sorry, I'm so sorry, I'm interrupting. मेरा एक request ये था, अभी देखिए, अभी हम लोगों ने पूरा जो theoretical part और वो सब समझ लिया. Maybe in very simple words, पहले आप explain कर दीजिए कि ये हम हमारा ये equipment क्या है, क्या ये मोटर है, क्या चीज है, हमारा challenge क्या था, और फिर उसके बाद आप you can build on the कि क्या किया आपने. Just एक brief पहले challenge एक बार बता दीजिए, उसके बाद then you can come to the solution part, please go on.
Yes, sir. Actually, this is the plan. So what this is, the slide is showing, sir. So this is our nitric acid plant. This is CNA, concept nitric acid plant. This is CNA5 plant. So there is one critical pump, the NGN pump. Okay, this pump is very critical for preparing the concentrated nitric acid. So there is no standby pump for this because this MGN should be operated only on above 80 degrees centigrade. Okay, that's why there is only one pump. This pump stops, the whole process will stop, and this will impact a big production loss for our plant.
थोड़ा सा माइक के पास आ जाइए चंदन जी, थोड़ा सा माइक के और पास आ जाइए.
Okay. Now it is okay, sir?
थोड़ा सा बेटर है अगर हाँ, please go on.
Okay. This was one of the critical equipment. So if actually that one incident has happened, so that coupling has been failed previously in December 2019. The coupling has been damaged, and only that motor is only rotating. The pump is not rotating, and this will impact on big loss. हम लोग का बहुत प्रोडक्शन लॉस हुआ है सर. इसका वजह से हम लोग जैसे सोच रहा था, जैसे वाइब्रेशन सेंसर को हम लोग प्रोक्योर करेंगे, ऑनलाइन मॉनिटरिंग ऐसा करेंगे कुछ, जैसे हम लोग सोच रहा था. जैसे हम लोग इंटरनेट में ढूंढ रहा था, हम लोग को बहुत सारा वेंडर मिला है सर. तो बेस्ड ऑन दैट वी आर सिलेक्टेड इनफिनिट अप टाइम. तो हम लोग क्या रिक्वेस्ट किया सर, उन लोगों को डेमोस्ट्रेशन के लिए हम लोग रिक्वेस्ट किया था. वो लोग आके डेमोस्ट्रेशन किया था. 1 month हम लोग सेंसर इंस्टॉल किया है सर. उसको पूरा हम लोग रीडिंग वगैरह मैच किया सर. हम लोग को इम्पैक्ट हुआ जो ऑलमोस्ट हम लोग को सेटिस्फाई हुआ है सर. सो बेस्ड ऑन दैट हम लोग 20 सेंसर को प्रोक्योर किया है सर. सो वंस अगेन दिस पंप में सर पंप बेयरिंग फॉल्ट हम लोगों को दिखा रहा था सर. सो हम लोग ये पंप बंद करने से पूरा प्लांट बंद हो जाता था हमारा. तो हम लोग इसको 3 months हम लोग मेंटेन किया है 24/7. ये अगर 4.5 हम लोग इसका वाइब्रेशन लिमिट लगा है, 5.2 आने से भी, 4.6 आने से भी सर हम लोगों को अलर्ट आता था. एंड ड्यूरिंग लॉकडाउन टाइम ऑल्सो हम लोग घर में बैठ के इसको पूरा कैसा है और कितना दिन चल सकता है और कितना इसका लाइफ है। अगर इसको हम लोग बंद करते, प्लांट बंद करता था, बट हम लोग इसको बंद नहीं किया। तो थ्रू सेंसर ओनली वी आर मॉनिटरिंग द इक्विपमेंट इन, हम लोग घर में बैठ के पूरा मॉनिटर किया। सो हम लोग बाद में शटडाउन टाइम में पंप को बेरिंग रिप्लेस किया। अभी इसमें स्मूथ रन हो रहे सर। दिस वाज द वन केस स्टडी I want to share.
Okay.
And another case study, sir. So this was the FFT. Sir, put us please back to the previous slide. So this was the FFT before and after the replacement of bearing. And almost 3 months we are maintaining the data. We are monitoring the data through the sensor. Next slide, sir. Okay, so this was the captive power plant of 4 megawatt. This is the EJAC make boiler. So ये हमारा सर एक फैन है, एक FD फैन, PA फैन और ID फैन। तो हम लोग को एक FD फैन बंद करना चाहिए, पूरा प्लांट बंद करना है, बिकॉज अब हम लोग ये पावर प्लांट से स्टीम जनरेट करता है, वो नाइट्रिक एसिड प्लांट में यूज करता है। तो ये क्या हुआ था सर, एक फैन में हम लोग को फैन एनडी में बेरिंग लूजनेस हम लोगों को प्रॉब्लम मिला था। तो इसको भी हम लोग अभी इमीडिएटली बंद नहीं कर सकते क्योंकि प्लांट का प्रोडक्टिविटी के ऊपर डिपेंड है। इसको हम लोग ऑलमोस्ट 2.5 मंथ और सेंसर लगा के हम लोग मॉनिटर किया है 24/7। अगर हम लोग 8-9 वाइब्रेशन मेंटेन होता था, 9.2 होने से भी हम लोग को अलर्ट मिलता था। So this was a fabulous, we got a sensor and through 24/7 we monitor the equipment, and after shutdown we are replace the bearing with housing, and then now the equipment was running smooth, and almost 20 equipments we are installed a sensor in our plant, and now it was easy to monitor after going to home also. If any कुछ प्रॉब्लम में इश्यू आया, क्या कोई वाइब्रेशन, कुछ टेम्परेचर इश्यू है, कुछ साउंड में इश्यू है, इमीडिएटली से हम लोग को अलर्ट आता है। तो हम लोगों को अगर आना है तो हम आके और दोबारा एनालिसिस करता है, नहीं तो उधर ही बैठ के घर में सॉफ्टवेयर में पूरा बेरिंग फॉल्ट है क्या, टेम्परेचर का इश्यू है क्या, लुब्रिकेशन का इश्यू है क्या, थ्रू सॉफ्टवेयर ओनली हम लोग उस पूरा चेक करके हम आइडेंटिफाई कर सकते हैं सर। दिस वाज द स्पेक्ट्रम, सो बिफोर एंड आफ्टर रिप्लेसमेंट ऑफ बेरिंग एंड बेरिंग हाउसिंग। सो थैंक्स फॉर द अपॉर्चुनिटी for me to share this case study, sir. Thank you very much.
No, I think thank you so much, Chandanji, for sharing the insights. Can you go back to the Putta? Can you go back to the previous screen? To the previous screen, please. Are you there, Putta? Yeah. I think this screen, no. Till so far we were talking about role of condition-based maintenance only in manufacturing, be it discrete or in continuous plants. I think a very good point which has come up with this case study from Deepak Fertilizers is that not just for these manufacturing plants, but also for these utility plants. Like this is a classic case of a ISJEC boiler. We have Naresh Pathak who has worked with ISJEC before. I think this is from an ISJEC boiler, wherein this case is about the FD fan. FD fan is what the forced draft fan, which forces air through the boiler, and it actually it is because for a combustion to happen you have to have air, you have to have fuel, and it's oxygen. Everything has to be put together, and then only, and you have to have the right temperature so that the ignition can happen. So this FD fan case study brings out that we can also use it for these utility plants. And not just utility. I think like Vishwajit ji also mentioned that you can have these wind turbines or any other such power generating equipments or setups in which these kind of technologies can be put to good use. I think it's a good point. I think I will now request Amit Saluja from NASSCOM to give his views about the session and maybe talk about few aspects around usage of IoT in maintenance. Amit, if you are there, if you can unmute yourself, please.
Yeah, thank you, Atulji. I think this was a great session. I think this whole brings out the kind of and the way to really monitor the different events. For me, this is just like an ECG, correct? For a human being, we keep doing ECG only at a certain point of time to find whether there is some problem or not. And these signals which comes out of that analysis of the vibrations, it's purely gives the internals of the equipment. So I think that's the way the complete online monitoring of the equipments can be done. And I think Bishwajit ji and the case study from the Deepak Fertilizer, that this whole brings out the whole point that how important it is for all of us to continuously analyze the remotely, right? And really a lot of these failures that we were just talking about can be prevented. And the technologies are there. Right? While the vibration analysis meters have been there for long, but now with the use of the IoT-based technology, these can be remotely gathered the data, and then all the analysis can be done, and all the analysis of the patterns that Vishwajit was explaining. So through those analysis, we can really find out, I mean, whether equipment is going to fail or not. And once we know that there is some kind of changes in the parameters is happening, the way like doctor prescribes certain medicines or something, we can also take a timely action of these to prevent any kind of a future breakdown. And this itself can be a big savior of the cost and the time for the kind of manufacturers. So I think this was a great session. There's a lot of learning. Good to see that we are analyzing a lot of these patterns. I mean, I think Vishwajit has explained in a very simplistic way of how do we analyze it and find out what kind of defects can be there. So I think it was a great session.
Great. Thank you, Amit ji, for your good words of encouragement. I think I also want to highlight that Vishwajit ji also mentioned during his presentation about putting up these high-end and these expensive uh, setups from for companies like Bentley Nevada, who are experts in vibration monitoring. But those in those years and even today, if you see these equipments from companies like Bentley Nevada, they come at a premium. It's a very high cost investment. But as Deepak Fertilizer team member has just mentioned, and the other day also we got a view from Adani team member. So I think these the cost of IoT and related sensors and the monitoring has gone down significantly, and it can be well experimented by companies who want to do so. I think it was a good session. Thank you so much. And Putta, if you want to say something, fine. Otherwise, we can always hear you tomorrow. Yeah. And I think let's move on. I would request Kamal if you can please give your concluding remarks, and then we can conclude the session for today.
Yeah, so very interesting session on vibration today. So in first session, we learned why condition-based monitoring is important. Today, we learned that vibration is very important. And probably tomorrow, we will understand about weird debris analysis and all those things. So as an IT person, we need to understand, so putting sensor and getting data is very easy. But where to put the sensor and why to put that sensor, if as an IT person, we have that knowledge, it will make our task easier. We will be able to speak to our plant people in the same language which they understand. If we just say to them that we are putting IoT sensor and all those things, probably they won't be able to understand because they are not understanding our language. But we need to understand their language. We need to find out those use cases where actually we can put sensors and we can collect the data. So very interesting session and very learning session. I was reading one of the participants' view that it recalled our engineering days. Obviously, I also went back to my engineering days. So very good learning, at least for me. So thanks to IIPM people, thanks to Vishwajit ji for taking this session. Thanks to Amit Saluja from NASSCOM to give his views about this session. And thanks to all the participants who came today. Thanks to Deepak Fertilizer team, Chandan specifically. And last time Abhay was there from Adani Wilmar and Arkadeep was there from Adani Wilmar. So it is very good blend of theory as well as practical case study. So hopefully tomorrow also we would be continuing with that. And just to remind all the people that on 11th November we are doing another session where we would be bringing Paul Dupis, who was a rag picker, and we would be understanding his 5 leadership traits, and some lucky winners would be getting his book. So if you have not registered for that, register for the same and wait for the approval. Thank you all from CIOs of India.
Thank you. Thank you.
Thank you, sir. Thank you very much.
Thanks. Look forward for, please connect at 9 o'clock tomorrow so that we can start in time. Thank you so much.
Okay, thank you.
Thank you.